Okay, so ImageNet, I think this is the most popular data set for image classification, and we have roughly 1,000 categories, as we discussed earlier. We have 14 million images, and I think this is growing daily. They are increasing the size. They're collecting more images, and we have roughly 100K testing samples here. So this is like a huge data set. Just training like simple architectures on this model, if you don't have enough GPU resources, it takes actually weeks. And in that sense, it's challenging as well. Okay, so those were the data sets. Now you understand the high level idea of classification. Now the overall approach you take when you solve any classification problem is, given a training images, you have to separate those images into validation and testing. And again, we have covered these things before as well. So I'm going to quickly go over these. Okay, so the idea is validation images are something when you train your model on these training images, you evaluate on these images, and depending upon whether your model is performing well or not, you can try to you can try to fine tune your hyperparameters, right? For example, if you want to increase your learning rate, decrease the learning rate, or you want to change the number of layers in your model, if you want to use like more kernels. So all those hyperparameters you can change depending upon how your model is actually performing on this validation set. And testing images, again, you don't have like labels to these. They will be only used for evaluation. And you don't use like feedback on this test set to actually improve your model. Okay. So the learning phase will be, you will have your training images, you will extract features, and then you will train your classifier over here. And to train that, you know that you need the ground truth labels. In this case, classification, you will only need which object is actually present in your training samples. And that will give you like the training signal, which for which you can have a loss function. Okay. And at the end of this, you will get a train classifier, which you will run on your testing images. And again, for testing images, you will use the same feature extraction steps, and you will use the training model to make the final prediction. And of course, you will have labels for these testing samples, and you can evaluate how good your model is doing. So that's like overall training process, which you have to take. Now, let's quickly go over these features as well, what kind of features you can use. We can have raw pixel values. We can use directly those. We can use histograms, for example, HOG features or SIF features. We can have templates. And there are a lot of like other set of local features which are actually very useful for classification. And eventually we'll have, so this is something like which we will focus on this lecture. And we'll not specifically talk about these features because we have already covered like how we have to extract HOG and SIF features, right? Those are some of the variations. But what we will cover is how to use those features to solve the classification problem, because this is just the first step, right? And later on, we will see like, what if we don't want to use those extracted features? What if we want to learn those features? So in that case, that's the second part of this lecture where we'll talk about how without extracting these features, we directly train your model end to end by directly operating on your input images.